Hello, my name is Sam. This is my first video in hopefully an installment of videos on GCSE Maths. We're starting with some quadratics work, as quadratics is one of, if not the most important topic in the whole GCSE Maths syllabus. It comes up all over the place and it's really good to get a hang of this stuff. So this is an introduction to quadratics and how we can factorise them. So let's start with this expression here. So this is an equation to start. We won't be solving it just yet. We will just be factorising this bit here before the equals sign. And what do I mean by factorise? Well, I want to take this expression and put it into brackets. So we want to make a double bracket that when expanded equals this expression. So there is going to be an A term here and a B term here. This line is not important. So why do we want this? Well, if I expand this, I'm going to get x squared plus ax plus bx plus ab, which simplifies to x squared plus, and then I can factorise the x out of both of these. So it's x times a plus b, and that is plus ab. So we are looking for two numbers, a and b, which will add to make 5 and multiply to make 6. And we can see as well here that it doesn't matter which is which, so it doesn't matter which of the numbers a is and which of the numbers b is, as they're both just added and multiplied here. So what two numbers are they going to be? Well, I can give you a second to think about that, but it is going to be 2 and 3, because 2 and 3 add to get 5 and they multiply to make 6. So putting those into the brackets, we have x plus 2 and x plus 3. Again, it doesn't matter which way round these are, as it still all comes out the same. And this works because if I substitute 2 in for a here and 3 in for b here, 2 plus 3 is 5 and 2 times 3 is 6, which gives us this original expression. In this case, this is an equation and this equals 0. And we will learn how to solve these in a later video. For now, we are just factorising, and this is our answer. So this is the first type of quadratic. This is where the coefficient of x squared, which is the number that comes before the x squared, is just 1. There is a 1 here, which we cannot see, but this case is for when there is a 1 here. Now, what about a case where that is not true? So this is our second example. Here we have a 2 in front of our x squared term, and that kind of throws everything under the bus, as we cannot just look for two numbers that add to make 5 and multiply to make 3 anymore, as those two numbers do not exist, at least not normal numbers. So what are we going to do here? Well, again, we're going to want to factorise this into brackets with next term and a 2x term. The reason for this 2 is that the x times the x gives us the x squared, but we need to have a 2 in one of these brackets to give us our answer. We are then also going to have our a and our b, but we cannot factorise this how we have done before. We need a new method. So if I'm going to expand this out, this is going to equal 2x squared. Actually, I'm not going to expand this out. I will just go through what we're looking for. So we are looking for two numbers which are going to add to make 5, and we are looking for two numbers which are going to multiply to get 2 times 3. So let's do a little table here. Add to make 5 and multiply to get 2 times 3, which is 6. So what numbers add to make 5 and multiply to get 6? Well, it's the same as the previous example. It is 2 and 3. Now this does not mean that our a is 2 and our b is 3. We have to do a new method. So I'm going to rewrite the expression as 2x squared plus 2x plus 3x plus 3. Now this 2 and this 3, they add to make the 5. So we have not changed the equation at all. We have just written it out in a new way. So what am I going to do here to solve this? Well, I'm going to draw a dotted line down the middle, and we're going to treat this equation in two halves. I'm going to factorise this half, and I'm going to factorise this half. So what about the left half? Well, out of both of these terms, I can pull out a 2 and I can pull out an x. That leaves just an x term on the left and a 1 on the right. And what about this side? Well, I can pull out a 3 from both of these terms. And that again leaves us with an x plus 1. Now in these cases, when we're solving this kind of quadratic, we will always be left with the bracket here will be the same. So what is our actual answer? Well, we're going to factorize the x plus 1 out of both of these. And that leaves us with a 2x plus 3. And that is our answer. Notice that our a and b, which we had, 2 and 3, are not these numbers here. But that will be the correct factorization for this expression. Again, if this was equal to 0, then these two brackets would also be equal to 0. And again, we will learn how to solve these in a later episode. Moving on to the third type. Now this looks a little different, as it does not have an x term in the middle. Just to clarify, this is an 8. So there is no x term in the middle. We don't have it in the normal form, which we have just seen, ax squared plus bx plus c, which is a common way of representing quadratics. Instead, our b is equal to 0 and our c is negative. So what are we going to do here? Well, this is a special case. Again, we are looking for x times by something and x times by something, except our a and our b are going to cancel out. When we expand this expression, we're left with x squared plus x a plus b plus ab. This is the same as in our first example. And here we want a plus b to be equal to 0. And we want ab to be equal to 81. Now instead of thinking about, well, let's think of two numbers that add to make 0 and let's think of two numbers that multiply to get 81, we can notice that both of these numbers, 81 and x squared, are square numbers, which means that they both square root to be normal things. The square root of x squared is equal to x, and the square root of 81 is equal to 9. And this is a special case where you have to recognize that that is true. You need to recognize that this is a square number and this is a square number. It may also be the case that you could have 4x squared minus a number, given that this a is a square number. 4x squared can still be square rooted to equal 2x. So that should also be noted that this is a case that can pop up in the exam. So what's our answer going to be? Well, in this special case, the only thing we need is x plus a number, x minus a number, and that is going to be the square root of this second number here, 81. So it's going to be x plus the square root of 81 times by x minus the square root of 81. 81 square rooted is 9, so this is x plus 9, x minus 9. And this is a very common example, so you may get some others like x squared minus 144, and this will factorize into x plus 12, x minus 12. And it's very important that these are different. So we have a plus here and we have a minus here. That is because when we expand these terms, so I'll just get rid of this example. If we expand this expression, we are left with x squared plus 9x minus 9x minus 81, which simplifies to x squared minus 81. And this only works as well when this is a minus. If that is a positive sign, then this method will not work, as we need these two numbers here to cancel. Okay. On to our fourth and final example, we have this one. So this is very similar to what our second example looked like. Our coefficient of x squared is not 1, it is an actual number. We have an x term in the middle and we have a normal term on the end. However, this is not good, because this example does not factorize how we would expect. There is no way to take this and to make it what we want. Let's try first. Let's try two numbers that add to make 9 and multiply to get 3 times by 1. So two numbers that add to get 9 and multiply to get 3. Unfortunately, it is not possible. So we are going to need to use the quadratic formula and see if there is a solution to this expression. The quadratic formula, x equals minus b plus or minus the square root b squared minus 4ac all over 2a, where this is a, this is b, and this is c. We can substitute these numbers in here to get minus 9 plus or minus the square root of b squared, so this is 9 squared, which is 81, minus 4a, which is 3, and c, which is 1. And this is all over 2 times by a, which is 2 times by 3, which is 6. Now, we could do this by ourselves, but instead we can get out our calculator and we can have it calculated for us. I'm going to just keep going with this for the time being. So we have minus 9 plus or minus, and we have a plus or a minus because there will be 2 solutions to this question. And this is the square root of 81 minus 4 times 3 times 1. 3 times 1 is 3, 4 times 3 is 12. So this is 81 minus 12, which is 69. This is all over 6. Don't worry about solving this for the time being. This will be a third. We will have to simplify this. There is a minus 9 and there is a 6 here. But when you continue with this, if you put it into your calculator, you will get 2 correct solutions. Okay, so those are our 4 examples. Let's do a quick recap. We have number 1, 2 numbers that add to make the x term and multiply to get the term which is by itself. And you simply put those in brackets, and that is a correct factorization. The second one, where the coefficient of the x squared term is not 1, we have to look for 2 numbers which will add to make our x term and multiply to get our x squared term and our, 2 numbers which will multiply to get our x squared term multiplied by our final term. We then split our equation in half, factorize out the bracket here, which is in the middle, and we get our answer, a correct factorization. The third method is our difference of 2 squares, where we have a squared term subtracting another squared term, where the answer is simply x plus the square root of that second term times by x minus the square root of the second term, 81. And then we have number 4, which is not easily factorizable, and in fact we have to use a quadratic formula to solve this expression, as we cannot easily factorize it. Okay, thank you for watching.